Hi everyone. In this video, we're going to look at how we can modify the element coordinate system or local coordinate system of shell elements that we've created after the meshing process. So to introduce this, I've got a fairly simple model here that I'm working with in SRAM. It's got three different panels, and these three panels are of different shapes and sizes, and I've also deliberately defined them with different orientations. So for a bit of background, the element local coordinate system of a panel is defined based on the order that you define the joints. So when I was clicking, for example, this first large panel, I clicked at this point here right at the origin, which would be the I point. Then at this point here, at the point of grid line intersection is K21, that was the J point. And they continued on in this direction. So that basically dictates the direction of the local x-axis, among other things. For this top panel on top, I defined it in the opposite direction. So this is the I joint. This is the J joint, and this was the K joint, and just continued in that kind of clockwise manner. And I had something similar here with this triangular shaped panel, except obviously I have 3 points, and so there is an angle as well included. So what I'm going to do is I'm going to actually generate the shell elements to create this mesh. And I'm just using default meshing parameters. The mesh that we're producing isn't really too important to the end outcome of this exercise. But what I wanted to do here is just go through this exercise with clicking on the mesh operation tool. And you can see here that it's confirming the panel. It's asking me to confirm the panel mesh density, hole density, and so on. I just have panels that have been created here. So I'm just going to click the yes button. And what I'm actually displaying here is with the shell element tool, the quadrilateral element tool in this case, I'm displaying the local x, y, and z coordinate systems. And we can see here, if we just zoom in, and maybe it's easier to see in 3D view actually, I can see that for each individual panel, all of these coordinate systems are aligned with the panel's coordinate system. So each shell has its own axis, and it's showing those coordinate systems. And you'll notice here that we don't actually have consistency between these. So as we can see, we have our x-axis for this shell, this set of shells here, going in the x-axis direction of the global coordinate system, happens to overlap. Whereas for this one, it's going in the opposite direction, and our z-axis is actually pointed down. And we can see as well, for our triangular shaped panel, it's produced a unique coordinate system that's in line with the angle of this slope. Now what I can do is I can say, let's just change this so that all the coordinate systems are in the same direction. And I can use the existing coordinate systems that I already have. In this case here, I just have a global system, which is with respect to this global coordinate system, the x, y, and z shown in red. Or I could create my own coordinate system, which I'll look at later. And what I can do now that I have those is I can use the quadrilateral element tool, which will only adjust the quadrilateral elements in my model, not the triangular elements. I can use this, and I can then select on this modify menu here. I can select, rather than modify all, I'm going to modify the ECS. And I'm just going to select the UCS that I want to modify to. So I'm going to click global system. And I'm going to left click, and I'm going to drag around all of these elements here. And we can see now it's aligned those shell coordinate systems with one another, at least for the quadrilateral elements. So I would have to do the same thing for the triangular elements, as those aren't affected by that operation, which only affects the quadrilateral elements. So here I'm just going to keep the same settings, modify ECS, global system, and left click and drag, and you can see it's modified those ones as well. And this can be handy if we want to view the coordinate system, the results relative to a specific coordinate system that may not necessarily be one that was created during our original meshing operation. And I can take this a step further and say, you know what? Let's create my own coordinate system using the UCS tool. And I'm going to create it by defining a coordinate system with 3 different mouse clicks. So I'll click on this 3-point method. And I'm going to start by clicking at this point here. This will be the origin of my new coordinate system. I'm going to start by defining the x-axis, which will be defined from the start point to the second point here. I'll left click right here. And then finally the direction of my y-axis. I'm just going to say it's going to be in this direction here. Obviously orthogonal to the x-axis. And now we're producing this coordinate system at a skew from the original coordinate system. And I can save this, and I'm just going to click on the Save UCS button, and give it a name. I'll call this angle UCS. I'll click OK. And let's just repeat that process. I'll go back to the quadrilateral element tool. And everything is nicely aligned with my UCS, my global coordinate system, sorry. But now I'm going to modify the ECS by using this angle UCS rather than the global system. And I'm just going to left click. Oh, sorry, I clicked too soon there. Left click and drag. And you can see here we got a bit of a preview with my mistaken click there. It's essentially rotated everything to that new coordinate system orientation, with the exception of the triangular elements, which I'll do as well right now. So this can be a pretty handy tool because there are reasons why we might want to view results relative to an element coordinate system rather than a global coordinate system. And this allows us to align that coordinate system in the way that we like.